Warm wishes and greetings to everyone. Today we are going to see about the Macaulay's method of video lecture, which consists of a point load and partial UDL. A simply supported beam AB, which is of span 5 meter, is having a point load of 20 kilonewton at a distance of 2 meter from the left support A, and an partial UDL of 10 kilonewton per meter run over the span of 3 meter from point load to the next support B. The point load position I called as C, the left support point as capital A, the right support point as capital B. Now, using Macaulay's method, how to solve this type of problem? So point load and partial UDL. So here you have to find the reaction at the support A and B that I called as R suffix A and R suffix B. So therefore, taking moment equilibrium at B, what will happen? VA into 5 minus 20 into 3 minus 10 into 3 square by 2 is equal to 0. So this is one moment equilibrium at the support B. And from this you can get the value of RA, the reaction at the support A. So RA into 5 is equal to 20 into 3, that is 60 kilonewton meter, again plus 10 into 3 square by 2. So 5 into 3, 15, 15 into 5, 75. So that is equal to, you are getting a value of, what is that? 20 into 3, 60 plus 75. So 60 plus 75 is equal to 135. Then RA is equal to 135 divided by 5. So it is 135 divided by 5 kilonewton. So the vertical reaction at the support A is equal to, RA is equal to 135 divided by 5. So 135, that is nothing but, so 2 into 3, so 23 kilonewton. Similarly, you can apply the vertical equilibrium to find the reaction VB or RB. So the total load is 20 plus 3 into 3, 9. So it is 20 plus 10 into 3, 30. So that is 50 kilonewton. So 50 kilonewton is the total load. So you know RB is equal to 50 minus 23. So it is 27 kilonewton at the support B. So RE and RB are 23 kilonewton. Here at the other end, support RB is equal to 27 kilonewton. If you add, you will get 50 kilonewton. So therefore, the reactions are correct. So total reaction is equal to total downward load. So 50 kilonewton we are getting. Then we have to form the famous equation EI d squared by dx squared is equal to 23 into x plus c 23 into x, that is for the first region AC. Then dotted line, that is called as partition line, minus 10 into x minus 3 whole square by 2. So this is the moment equation. I call this as equation number 1. Then you have to integrate this moment equation twice. So you will get the constant C1, C2 in the case of slope dy by dx, that is equal to, right, theta. We are putting it, you will get 1 by EI of that value plus C1. And if you are once again integrating, you will get another equation which is called as a deflection equation, generally in terms of the integration constant C1, C2. So therefore EI dy by dx, you will get constant C1, and EI y is equal to, you will get, integrating once the slope equation, you will get some value plus the constant C2. There are two integral constants C1, C2 that can be determined by taking the known boundary condition. There are two boundary conditions here. That is, at x is equal to 0, the deflection is 0. You substitute in the deflection equation, I call it as number 3. Slope equation, I call it as number 2. So if you are substituting it, you will have one general slope equation. Then if you are substituting a second boundary condition, when x is equal to the other support end, x is equal to 5 meter, that is at b, again the deflection y is equal to 0. Substitute in the deflection equation, that is equation number 4. So if you are solving for C1, C2, you will get the corresponding value of the equation. You substitute in the general slope and deflection equation. Now you will get the final slope and deflection equation of these 5 and 6. Equation number 5 and 6 are the final slope equation, deflection equation. So you, by using this final slope and deflection equation, you can find the slope and deflection theta and y wherever you substitute x is equal to 1 meter, then x is equal to 2 meter, or x is equal to 3 meter, or x is equal to 4 meter. You can find the slope at the corresponding distance of x is equal to 1 meter, 2 meter, 3 meter, and 4 meter from the left hand support. So like that, you can find the corresponding value at any point, or once you form the slope and deflection equation. So that is equation numbers 5 and 6. So thank you very much for patient listening. God bless. Valga Vayagam. Valga Valam.